Hi Precalc, this is just a video of myself going through the 5.4, 5.5 review on triangles and some trig stuff. So feel free to skip around to what you need to see or watch the whole thing. So first of all, we have triangle MNO. We know that angle N is 90 degrees and that's already marked in the diagram, so that's nice. Find the 6 trig ratios for M, okay? So trig ratios, that is your SOHCAHTOA. So I would maybe start by writing that down. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then cosecant over here on the right side, that is the reciprocal of sine. So hypotenuse over opposite. Secant is the reciprocal of cosine. So hypotenuse over adjacent. And then cotangent, reciprocal of tangent, which is A over O. Okay? And all of these have to do with angle M. We are not switching the angle, so we're talking about this angle M each and every time. Okay, now we have a missing side here. We are missing side little m. So the first thing we want to do is find that, and the way we're going to do that is by using the Pythagorean theorem. So our 11 has to be C, and then 5 and this m, they're the legs, so they have to be our A and our B. So we're going to do 5 squared plus m squared equals 11 squared. 25 plus m squared equals 121. Subtract 25. And m squared equals 96. Take the square root of both sides, and m is the square root of 96. And we're just going to leave it like that. Okay? So if we are finding sine, well, first of all, I'm going to label all of these sides. I'm going to erase our A, our B, our C. I'm going to label each of these sides according to our angle M. Okay, so 11 is the hypotenuse. Across from angle M, this is our opposite. And then 5 is our adjacent. So from there, it's just a matter of substituting the numbers in where they go. So sine of angle M, O over H. In our case, square root of 96 over 11. Cosine is A over H, so 5 over 11. Tangent is opposite, which is the square root of 96 over adjacent, which is 5. Cosecant, hypotenuse is 11 over opposite, which is the square root of 96. I would probably rationalize the denominator there. So multiply top and bottom by the square root of 96, and you get 11 square root of 96 over 96. We don't like to have square roots in the denominator if we can avoid it. Not the biggest deal ever right now, but something we should maybe know. Secant is hypotenuse over adjacent, so 11 over 5, and then cotangent is adjacent 5 over opposite square root of 96. Once again, let's multiply the top and bottom by the square root of 96. And we get 5 square roots of 96 over 96. Moving on to number 2. Solve each problem using triangle ABC. Measure of angle C is 90 degrees. Round each answer to the nearest tenth. So I'm just going to keep using that triangle at the bottom there, and I'll erase it after each one. So first one, we have angle A is 23 degrees. And we have little b, which is over here, is 7. And we are supposed to find little c, which is our hypotenuse. Okay, so we need to label what else we know here. We know this side of 7, which is adjacent to the angle that we are given. So we have an A and an H, which means we're going to be using cosine. So we are going to have cosine of 23 is equal to adjacent 7 over hypotenuse C. And then this is one where we have a little bit more work because the variable is in the denominator. So we can multiply both sides by c. So now we have c times cosine of 23 is equal to 7. And then we have to get rid of times cosine of 23, so divide by cosine of 23. So now we have c is equal to 7 divided by the cosine of 23. Make sure when you're using your calculator, whether you're using Desmos or a TI, you're in the right mode. So I'm going to go to mode, change it from radians into degrees. And then we are doing, what, 7 divided by cosine of 23. 7 divided by cosine of 23. And rounding to the nearest tenth, we get about 7.6. Alright, gonna erase everything and do the next one, letter B. So we have big B is 71 degrees. And obviously this triangle, it doesn't look right for all of them. That doesn't look like a 71 degree angle, but that's just fine. Little c, or side C, is 13. And they want us to find little b over here, okay? So look at your 71 degree angle. You have the opposite side, or you're looking for the opposite side. You have the hypotenuse. O and H is sine. So sine of 71 is equal to opposite, which is b, over hypotenuse, which is 13. That's an easy one. To solve it, all we have to do is multiply both sides by 13. So grab your calculator, type in 13 sine 71. And you get approximately 12.3. Letter C. This time we have little b is 12. Little c is 17. And we are looking for big B. We're looking for that side there. So according to big B, we have the opposite side. We have the hypotenuse. So that's going to be a sine. So sine of our unknown angle, we don't know what B is, so it just stays B. It's equal to opposite 12 over hypotenuse. And then remember, oops, not H, 17. Remember, if you need to get something out of a trig ratio, out of your sine, cosine, or tangent, you need to take the inverse of both sides. Okay, so you are typing in your calculator inverse sine of 12 divided by 17. So second sine 12 divided by 17. And you get about 44.9 degrees. On to letter D. Let's see. Back to using blue. Angle A is 46 degrees. Little b is 9. And we are supposed to find little a. So little a is across from big A. Okay, so in this case, we are given the adjacent. We are looking for the opposite. That's going to be tangent. So tangent of 46 is equal to little a over 9. And that's an easy one. We like it when the number is on the bottom, because then all we have to do is multiply both sides by 9. Those are gone. And a is equal to 9 times, 9's and my a's look the same, 9 times tangent of 46. And we get about 9.3. And then the last one of these, we have little a is 4, that's down here. Little b is 5 right there, and we are looking for a. So according to that angle A, we have the opposite side, we have the adjacent side, so that's a tangent. So tangent of A is equal to 4 over 5. And then remember, to get rid of a tangent, to get that A out of there, take the inverse tangent of both sides. And that's pretty simple to type in your calculator. Just second tangent second tangent, 4 divided by 5. And you get about 38.7 degrees. All right, moving on to some word problems. We have Matt here. Matt is looking and sees his friend on the roof of Armstrong. If the angle of elevation to him and his friend is 42 degrees and Matt is 200 feet away from the building, how high is Armstrong? Round your answer to the nearest tenth. Okay, so in problems like this, I just kind of visualize, here's Armstrong. It is straight up and down building. It's not the Leaning Tower of Pisa or anything like that. Straight up and down. So here is, who is that? Matt's friend or Matt? Nope, his friend. His friend is up there. Okay, and then Matt is over here on the ground. Now we can kind of make ourselves a right triangle. Okay, we're given some information like the angle of elevation is 42 degrees. That's going to be this angle here. We're also given Matt is 200 feet away from the building. So that distance there is going to be 200. There's Matt. There's the bottom of Armstrong. And then our question is, how high is Armstrong? So this is our unknown. The height of Armstrong is unknown. So to solve this problem, we need to label what we're given and what we're looking for. So what we're given is adjacent to 42 degrees. What we're looking for is opposite. That's going to be a tangent. So tangent of 42 is equal to opposite x over adjacent 200. That's a good one, an easy one. We're just going to multiply both sides by 200. Type in your calculator, 200 times tangent of 42. And you get about 180.1. And that's going to be in feet. So Armstrong is 180.1 feet. Wow, that's pretty high building. I don't think that's accurate. All right, number 4, Tom. Tom decides to join the circus and get shot out of a cannon. Lovely. If he is shot out at an angle of 40 degrees and is flown for 35 feet, how high above the ground is he? Round your answer to the nearest tenth. Okay, so here's Tom at the beginning, and he is shot out of a cannon. Like so. That distance there, they are saying, is 35 feet. He has traveled kind of diagonally 35 feet. Okay? And obviously he's gone kind of a horizontal distance and he's now off the ground. So there's our triangle. This angle here, they are saying is 40 degrees. And the question is, how high above the ground is he? What's the height above the ground there? So once again, label what you have and what you're looking for. We have the hypotenuse in this case. We are looking for the opposite. That is a sine. So sine of 40 is equal to x over 35. Multiply both sides by 35. 35 times sine of 35 sine of 40 is about 22 and a half feet. 22 and a half feet. So you could answer that kind of however you want. You could say 22 feet and 6 inches, or you could say 22.5 feet. Either way, it'll be fine. And then number 5, you're skiing on a mountain with an altitude of 1,200 meters. Okay, I see the word altitude. To me, that means up and down. So I'll fill that in right away. The angle of depression is 21 degrees. Okay, this is where things get a little bit tricky. Angle of depression, remember, is from horizontal downward. So it's this angle here is 21 degrees. Okay. Now, if you kind of complete your right triangle that you're working on, so what are they going to ask us? They're going to ask us how long is your path if you're going straight down the mountain. So they're asking you for this distance here. Well, that 21 degrees on the outside of our triangle isn't super helpful right there, but remember that you can always stick that angle down here. The angle of elevation and the angle of depression are always the same, so you can stick it down there in your triangle. Now you are given the opposite side. You are looking for the hypotenuse, so you should be good to go there. So we are going to say sine of 21 is equal to opposite 1200 over x. This is one that's more work. You got to multiply both sides by x. So x sine of 21 is equal to 1200. Then divide by the sine of 21. And you are typing in your calculator 1200 divided by the sine of 21. And you get 3348.5. And that is in meters, 3,348.5 meters. All right, moving to number 6. For the following, use the patterns for special right triangles to find x and y. So what I like to do when I get to problems like this is just remember the rules. For 45, 45, 90, your rule is kind of your hypotenuse is the short side, or the leg. I guess you just call it a leg times the square root of 2. And then the rules I like to use for 30, 60, 90 are your hypotenuse is 2 times the short side, and your long side is your short times the square root of 3. Those are the ones that I'm going to use as I go through here. So for this first one, we have a 30, 60, 90. So I would label across from the 30 is your short side, across from the 60 is your long side, and then across from your right angle is your hypotenuse. So that's pretty easy when you're given the short side. The hypotenuse is just twice that, so 4. And then the long side is just that short side, which is 2 times the square root of 3. And then you're done. Not number 2. The next one there is a 45, 45, 90. So the sides that make up the right angle are going to be the same. So if one side is 9 square roots of 2, the other side is 9 square roots of 2. And then to get y, to get the hypotenuse, you take that side or either one of those legs and multiply it by the square root of 2. So you have 9 square roots of 2 times the square root of 2. The square root of 2 times the square root of 2 is just 2, and 9 times 2 is 18. So your hypotenuse there is going to be 18. Moving on to the next one, another 30, 60, 90. Here's your short side, here's your long side, here's your hypotenuse. So remember, your hypotenuse is twice as long as your short side, which means if your hypotenuse is 10, your short side is 5, and then your long side is that short side times the square root of 3. So x is 5 times the square root of 3, and y is just 5. Moving on, you have 45, 45, 90. Your hypotenuse is over here, and your legs are here. So kind of using the formula, your hypotenuse is equal to a leg times the square root of 2. So if you substitute some stuff in here, your hypotenuse is 16 square root of 2, and your leg is unknown. We can use either one. We can call it y times the square root of 2. I mean, you can tell just by looking. What does y have to be for those to be the same? It has to be 16. Or if you really wanted to solve it, you could divide both sides by the square root of 2. You can see that those are gone. So 16 is y, which means that x is also 16. And then the next one, let's label our sides: short, long, hypotenuse. So let's see, x is going to be twice as long as our short side. So 5 square roots of 3 times 2, that's going to give you 10 square roots of 3. You're just multiplying those guys together. So 10, where's that one? That's our x. 10 square roots of 3. And then our long side, that's going to be our short side. So 5 square roots of 3 times the square root of 3. Square root of 3 times the square root of 3 is 3. 5 times 3 is 15. There. And then last one, this is probably the easiest one on there. Both of your legs are the same because it's a 45, 45, 90. These are labeled the same. Both 45. So y is 8, and then x is going to be 8 times the square root of, oops, not 3. Square root of